Okay, we're going to start doing some weighted average problems, and it's mixture problems and rate, time, and distance, and a lot of different types of problems, but lots of information given, and we're going to organize everything in a table. So here we have assorted dried fruit. That's one thing we have, and it sells for $5.50. We're going to have some mixed nuts. We don't know how many of that, but we know it sells for $4.75. So it should be mixed with 10 pounds of the dried fruit, so that refers back up here, to obtain a trail mix that sells for $4.95. So again, a lot of information, so we're going to organize all this into a table. Excuse me. So in our table, we're going to have, and I use abbreviations out here, dried fruit, our mixed nuts, and then we end up with our mixture. And usually your mixture should be at the bottom. In this case, we're going to have the amount, the cost, and then I usually just say total cost. So going back, and if we read our problem, it says assorted dried fruit sells for $5.50. So dried fruit, $5.50. How many pounds of mixed nuts? So we don't know the amount of mixed nuts. That would be X. Selling for $4.75, so that would go here. And then continuing reading, should be mixed with 10 pounds of dried fruit, so that tells me how much dried fruit I have, to obtain a trail mix that sells for $4.95. So we want our mixture to sell for $4.95. So again, we're mixing dried fruit, which is a little more expensive, with mixed nuts, and then our mixture is going to sell somewhere in between. So how much of the mixture do we have is the first thing we really need to figure out. Well, remember where the mixture is coming from. Think of having a bowl here in the middle. What are you doing? You're pouring in the dried fruit, you're pouring in the mixed nuts. So how much of the mixture you're going to have? You're going to have those two added together. I usually put my X first. You can put 10 plus X if you want. And the total column of total cost is pretty easy, because if you're buying a pound of something that costs $5.50, well, it's $5.50 for every pound. And again, I don't do any math here, I just write it out. So 5.5, I'm going to drop that 0, times 10, 4.75 times X, and then 4.95 times the quantity, X plus 10. So please take the time to set up your chart, because now that's going to help us if we do our chart correctly. That'll help us do our equation, because the two things that we're mixing together added should equal the mixture. So that's going to be our equation. 5.5 times 10 plus 4.75x equals 4.95 times the quantity x plus 10. Now, calculator's fine to solve this, but you still need to show your steps. So 5.5 times 10, if we remember the easy way, we just move our decimal over. 1 plus 4.75x equals, distributing, we get 4.95x plus 49.5. So we need to get our x's together, so I'm going to subtract 4.75x from each side. And I get 55 equals 0.2x plus 49.5. So now I'm going to subtract 49.5 from each side. And I get 5.5 equal 0.2x. So I would divide by 0.2, and I would get x equals 27.5. So since this is a word problem, I do need a label, and we need to go back and make sure we answer the question. So the question that they asked us was how many pounds of mixed nuts, and notice, if you noticed up here in your table, that's where the X is, mixed nuts. So this would be 27 pounds of, and here you really can't use your abbreviations because they're not standard, so you do need to write out what it is. So 27.5 pounds of mixed nuts. So lots of information organized in a table, and that hopefully will make it easier for you. So let's try another one. This is more of a type you might have in chemistry or something like that, and it's mixing solutions together. So a chemistry experiment calls for a 30% solution of copper sulfate, so that's one of the types and it's 30%. She has a 40 milliliters of 25%, and she's going to mix a stronger one with it to get the 30%. So the 60% solution she's going to pour in there to get this 30%. So we're kind of mixing a weaker and a stronger to get something in the middle of the solution. So again, we're going to put everything in our table. Here you can call them solution 1 if you want. Oops, forgot to get my tool. Solution 1, or you can write out copper sulfate 1, something, I don't know. Solution 1, solution 2, and then our mixture. In this case, it's not really dollar signs that we have. We're still going to talk about the amount of it that we have, but it's the percent of how strong the solution is, and really this last one is then the amount of copper sulfate, which I'm just going to abbreviate CS for our purposes. So I'm going to read again. A chemistry experiment calls for a 30% solution. So that's the mixture that we want, 30%. When you do write your decimal, you need to write it in here, or your percent, you do need to write it as a decimal so we're able to use it and multiply with it. Kendra has 40 milliliters of a 25%, so it doesn't really matter which one is solution 1 and solution 2, just so you get them right. So she has 25%, or she has 40 milliliters is how much she has of a 25%, so that would be 0.25. And then how many milliliters of a 60%? So we don't know how much of the 60%, 0.6. Again, where is the mixture coming from? She's adding these two, solution 1 and solution 2 together. So that would be the total there. Now, sometimes you'll be given an amount of mixture and you'll have to reverse that, but we don't have one of those here. So again, the amount of copper sulfate would just be the two multiplied together. So 40 times 0.25, 0.6x, and 0.3 times the quantity, doesn't look like a 3 there, x plus 40. And again, since we have our mixture first, these two added together equal the mixture. So 0.25 times 40 plus 0.6x equals 0.3 times the quantity, x plus 10. Another way to think of 0.25 times 40 might be a 4, so that makes the math pretty easy. So we're just going to get 10 for that, plus 0.6x equals 0.3x plus, oops, I wrote that wrong, that should be a 40 there. So that would be 12. Again, I'm going to subtract 0.3x from each side. So I get 10 plus 0.3x equals 12. I'm going to subtract 10 from each side. Get 0.3x equal 2. Up here so you can see my last step, I guess. So now I need to divide by 0.3. And if I do that, I get x equals 6.6 repeating. So going back and reading what the question said, how many milliliters of the 60% solution? So let's just go ahead and round it. 6.7 milliliters of 60% solution. Sorry, looks a little sloppy there.